Okay, so now we're going to analyze this function, f of x equals 2 to the x minus 4. It's an exponential function, and the variable is in the power. So, a quick sketch is a very rough sketch. Here's what it is. It starts out very flat, and then it gets very steep as you move on along to the right. Now, the first thing we want to look for is the domain. You can plug anything in for x. You can plug in 0, 1, 2, 3, 12,000, anything over 9,000, anything under 9,000, negative 9,000, whatever. So, your domain is all real numbers, and we write that, again, if you remember, as negative infinity, colon positive infinity, with open parentheses on either end. Next is the range. We're allowed to plug in anything. Since we're allowed to plug in anything, we're allowed to get basically anything. But remember, this gets very flat, and it's very decreasing very slowly as we go on to the left. So we see that the range, it gets close to 4, but it doesn't reach 4. Well, negative 4. I'm sorry, negative 4. So the range, we write it as open parentheses 4, negative 4. Let me erase that. It looks kind of messy. You can't see the negative. Alright. The range is open parentheses negative 4, positive infinity. Increasing and decreasing intervals, well, its function is strictly increasing, so there's no decreasing intervals, and increases over the entire domain. The function obviously is not symmetric, we can already see that, but just for laughs, let's put it in. So, 2 to the minus x minus 4 is the same as 1 over 2 to the x minus 4. This function and that function aren't the same, so the functions are not symmetric. The function is also continuous over all x, so we say continuous over all real x. Asymptotes. Well, as you can see, the function, let me draw some of this back in. The function, if you go from right to left, you go down, you slide down, and then it gets very, very close to a very straight line, and it approaches this value, negative 4. So the asymptote would be the line y equals negative 4. This function doesn't have any extreme values at all. So we say none. And now for intercepts. For an x-intercept, we set this equal to 0 and solve. So that's going to be 2x to the minus 4, 2 to the x minus 4 equals 0. That's 2 to the x equals 4. And if we take the logarithm of both sides, logarithm base 2, we get x is equal to logarithm base 2 of 4, which is 2. So our x-intercept is 0, 2. Our y-intercept, if we set x equal to 0, 2 to the 0 minus 4 is equal to, well, 2 to the 0, anything to the 0 is 1, minus 4 is equal to negative 3. So it's going to be, oh, I did this backwards. This should be 2, 0. 2, 0, and our y-intercept is 0 minus 3. Alright, we're almost done. I have a small eraser that I can use. Now, the last two parts of analyzing this function are bound, are the bounds, and the end behavior over all x. So, well, first we can see that this function is bounded below, So we say bound below. And now our end behavior. So we write the limit as x approaches infinity of f of x. And, well, it's getting strictly higher. It's going higher as x gets bigger and bigger. So we say infinity. And for the limit, as x approaches minus infinity of f of x, well, it gets closer and closer to this value, this asymptote right here. Let me just draw it as a dotted line. It gets closer and closer, but slowly. So it reaches that asymptote, which is -4. And we are done analyzing this function.